Hi, my name is Mark Thomas, and I'm going to do a presentation today on how to use sliders in Excel, and we'll be using this tool to do some regression to fit a curve. My family went to St. Louis this summer, and we caught a picture of the St. Louis Arch, and we're going to use this picture to plot some data points. So what I did was I just overlaid it with a grid, and on the grid estimated through the middle of the curve the points that best represented the curve. And what we're going to do is we're going to fit actually a parabola to this, and I know it's not actually a parabolic shape, but we're going to use a parabola, a quadratic, to get a best fit curve for that. In order to do this in Excel, you have to have the developer toolbox available, and in order to enable it, if you click on the drop down menu and then make sure that you click on more commands and then go to Popular under the Excel options, you can click on the Show Developer tab in the ribbon. If you're using a different version of Excel, you can also just search for the Developer tab and make sure that you have that available to you. These were the data points that we looked at on the St. Louis Arch. So we have our input values and output values, and I simply typed them in. And I'm going to show you first of all what our final picture is going to look like, and then explain how to get there. So on our final picture here, what we've done is we've put in 3 sliders. So in our equation of an ax squared plus bx plus c, we have a value for a value for b, and a value for c coming off of these sliders. The next thing that you'll notice is over here off to the left side, I have an 8, a 1, and a 90. These are the values that are linked to the sliders. And of course, I would like values that are can be represented by decimals, and so depending on how fine-tuned you need something, what I did was I took each of these cells and divided by an appropriate constant to get it more fine-tuned for the certain parabola that we're trying to fit. And then from there we calculated values based off of our quadratic ax squared plus bx plus c, and you can see that they're roughly the same as our output values. And in the end, we have our picture that's here. What's nice is that as we go through this, you'll actually be able to see the data points change, or the approximate points change, as we try to fit our curve. Okay, so here we are in Excel, and I have the values inputted, and I'm going to show you where to go to find the ability to insert a slider. First of all, if you've turned on the Developer tab, it should appear. There are 2 buttons that we're going to use quite a bit here, which are Insert and Design Mode, and then also this Properties button as well. The Insert button is where we'll go first, so we'll click on it. You'll see we have an ActiveX control down here, which allows us to put in a slider of sorts, and we can put it in either horizontally or vertically. I'm going to go ahead and put one in horizontally here. Just stretch a box however long you want it to be. And then what I need to do is I need to look at the properties of this. So I'm going to come up to the Properties button. We'll click on Properties. And there are some cells that we want to look at whenever you do this. First thing we're going to do is we're going to look at large changes. And large changes will be different based on the application. But for a large change on this, we're going to make it 2. What this number allows us to do is every time we click in the middle of the slider, it's how much it increases by. The next thing we'll do is we'll jump down here and look at the small change. The small change is if you click on the arrows of the slider. It's how much it incrementally changes. And I'll just go ahead and leave that at 1. We need to link it to a cell, and the cell that I'm going to link this first one to is C1. And then we need to look at our max and mins. I'm going to make this slider run from 0 to 200. So on the minimum I'll put 0, and on the maximum we'll put 200. And we'll just go ahead and close that out. And as we look at our slider options, first of all you'll notice that I have the 6 white dots around it. That means that I'm in design mode. This design mode toggles on and off. So if I want to click on it again, now it's actually going to act as a slider. And once I start hitting the buttons on the slider, the value appears in C1 for this appropriate slider value. We're going to go through and do the exact same thing again and hook up one for C2 and C3. So what we're going to do is we're going to go to Insert. We'll go to our slider. We'll create a slider. And I want to go to the Properties. We're going to look at the large change, which I'd said we'll just change that to 2. And these could be different on each slider if you'd like. We'll leave our small change at 1. On this one, we're going to put this value in the cell called C2. So under the linked cell right here, it starts out as empty. So we're going to put a C2 value there. We also need to make sure that we put our minimum and maximum values. So I'm going to put 0 and 200 again. And again, we have our 6 white dots. This can be frustrating if you don't catch it, is that the slider's not active right now because I'm in design mode. So once I click on this design mode button, it now actually acts as a slider. And you can see that every time I click in the middle, it actually jumps by 2. And you can change that in the Properties button. In order to select a slider as a tool and not just as a slider, you do need to click on the design mode. So if we go ahead and click on the design mode, I can actually click on the slider, and if there were changes that we wanted to make here, we could make them by going back to Properties. So design mode allows you to set the settings within a slider. I'm going to go ahead and click on this slider. I'll copy it. I right-clicked on it, excuse me. I copy it, and we're going to go ahead and paste it. So what I've done is I've created an exact replica of this slider. I'm going to go ahead and take the Properties view of it, and you'll see that I have a large change value of 2, a small change value of 1, minimum from 0, maximum is 200. And the other thing that you'll notice is the link cell is at C2. I don't actually want it to be C2, I want it to be C3. So if you're going to create several of these, make sure that you link them to the cell that you want it to actually be linked to. Now whenever I get out of design mode, I can change these values separately. Now in order to create a parabola, I want to go ahead and use smaller increment values than just integer values or whole number values. So in this first cell right here in D1, I'm going to take the slider value that we found and I'm going to divide it by 100. So we'll go ahead and do an equal sign so it starts as a calculation, and we'll do C1 divided by 100. In the second value, with the second slider, I'm going to take C2 and I'm going to divide it by 10. And then the last one, I'm just going to copy over exactly what C3 is. And so this will allow us to fine-tune the value of A a little bit more than what we'd be able to fine-tune the value of C. Okay, the next thing that we're going to do is we're going to create values that are based off our quadratic equation rather than the data points that we had. We'll use the input data values that we have over here and put them in a quadratic equation. So the quadratic equation that I'm going to use is a negative value for A since it's opening downward, a negative value for B, a positive value for C. And so what I have is I have dollar signs in front of D and dollar signs in front of 1. So that way it uses this value for A in the ax squared plus bx plus c, which is actually found right here. So it's not going to change as we fill down. We're going to pull in our input value of A4. That will change as we pull down. We're going to square that because that's our input squared. I have another minus sign here. We're going to have a value of B using this $D $2, so that way it won't change as we fill down, times X, the input value, plus $D $3, so that way it continually uses this value. So those are the pieces that go into that. And then as we fill this down, there's a couple of ways of doing it. An easy way to do it is just look at the very bottom right hand corner of it. Whenever we turn to this plus sign, I can just drag it down and it will automatically fill it down. So these are the values that were based on a quadratic equation with coefficients of a, b, and c. And again, they are nowhere near the values that we're actually interested in. We'll have to fine tune that, and we'll actually do that from the graph. The interesting thing on this is that as we change our slider values, you can see that our approximate values for our data are automatically changing. So it'll update all of those as we go through. Okay. One exercise would be actually to simply change the slider values until you can approximate the output values just numerically and try to get a feel for what it should look like. We're going to actually do this graphically. So we're going to take a look at a chart and see what it looks like with that. We're going to insert a scatter plot. And so if we select our data that we want inserted, using the Insert tab, we can go to Scatter and choose a scatter plot to create. By adjusting now our sliders, the goal is to have our green values approximate the blue values that were the actual pieces for our St. Louis Arch. And we can just move these around until we find approximate values that seem to work well. Seems like we need some smaller values of A, our value of B. You can see that as we move those, it kind of changes our symmetry line. And then it definitely needs to move up. So we'll move it up, and that's looking pretty close right there. And maybe that one's a little bit better with a B value of 0.1. I hope you've enjoyed and learned quite a bit from this. If you'd like to see more videos that I've produced, you can see them at SHS M. Thomas.